Hello and welcome back to the lecture on applied econometrics. So we have been talking about expectation, variance and covariance. So in the previous lecture, we gave you the idea of expectation. Now before I get into covariance, variance and covariance, let me give you some rules of expectation that we need to keep in mind, okay. So the rules of expectation. So there are essentially three rules that we need to keep in mind, and the rules are following. So let us say a variable is represented by, let us say, x is equal to y plus v plus z, okay. Now the first rule says the expectation, if I take expectation of x is equal to expectation of y plus v plus z, so then that is going to be expectation of y plus expectation of v plus expectation of z. So what do you call it? The expected value of the sum of several, if we explain it. So the expected value of the sum of the several variables is going to be the sum of the expected value of the variables, okay. So this is the first rule. So if you have three variables representing a random variable, so you can basically get the expectation of each of this random variable and sum them up. So that is basically going to represent the expected value of x, okay. Now the second rule says, let us say I have a constant term b, so and I want to take and that is multiplied with a random variable. So let us say I have ax and I want to take an expectation of the whole thing, then what we are going to have is that is basically the product of the constant term and the expectation of the random variable. So basically it says that if there is a constant term inside, you can take that constant term out, okay. And third rule is that if you take an expectation of a constant term, let us say expectation of a, okay. So you can easily guess. So if you take an average of the constant term, of the same values across, n number of times, so what you will get is nothing but the same value, okay. So these three rules we are going to remember, and we are going to see the application of these rules. Now let me now go back to the concept of variance. So variance is a very widely used concept whenever we deal with empirical data, whenever we try to describe a population or sample. Variance is one of the main characteristics that we need to deal with. Now what is a variance? So we know when we deal with the frequency distribution, I presume you already know how to calculate variance. So we usually write sigma x square, and that we write 1 by n summation xi minus x bar square, right. So that is how we write. So it basically says that the sum total of all, basically you take the sum of all the dispersions from the mean value of, like if you have x's, different x's, you take the their difference from the mean value and then you sum them up. Now in the language of for a random variable, in case of a probability distribution, what we write it as v of x is equal to expectation of, just the same way, but here we write x minus mu whole square, okay. So it's nothing but the same thing, but we are representing in terms of the expectation term, right. Now if we sort of expand it, if we expand this whole thing, so it will be expectation of x square minus 2 mu plus mu square, okay. And expanding it further, what we will get is expectation. Now we go back to the expectation rules. So where we had the first rule, you can actually, if you have these three random variables representing x, so you can actually have the expectation as a sum of the expectation of individual random variables. So if we use this, so we are going to have expectation of x square minus 2 into expectation of x, and as we know this is a constant term. So as per the second rule, we can write 2 mu x, and third expectation of mu square, right. Now we know that expectation of x, that is the mean, that is going to be mu. So we can write expectation of x square, and then we can write 2 mu into mu square, and then again expectation of constant term. So, that is our third rule of expectation. So, that is going to be the same, that is mu square, right. Or we can write expectation of x square, and if we just add this up. So, I will have expectation of x square minus mu square, or sometimes we also write it as expectation of x square minus of expectation of x, which is mu, and that whole square. Okay. This is a standard formula for variance that we use, okay. And this is a formula that we will see we often use, and it is good to remember this particular form of this formula. Okay. Now, let us do an example and let us calculate the expectation. So, we will again use a previous example where we actually threw 2 dice. Okay. So, this place is really cluttered, but let me see if I can actually do something here. So, we had our expectation of x, which is 7, right. Now, if I want to get expectation, so basically x minus let us say mu. So, whenever I want to get the variance as per this formula, whenever I want to get a variance as per this formula, so I need to get the value of x minus mu, right, and the value of x minus mu are going to be here. So, this is going to be 1 minus 7, which is minus 6. This is going to be 2 minus 7 minus 5, then 3 minus 7 is going to be minus 4. It is becoming very small, or I should actually use a thinner pen. So, 1 minus 7 is minus 6, then 2 minus 7 is minus 5, 3 minus 7 minus 4, 4 minus 7 minus 3, 5 minus 7 minus 2, 6 minus 7 minus 1, 7 minus 7 0, then 8 minus 7 1, then 9 minus 7 2, and 10 minus 7 3, 4, 11 minus 7 4, and 12 minus 7 is 5. Okay. Now, if I want to square this the terms, so I am going to have 36, 25, because I need to have x minus mu square. So, that is going to be 16, then 9, then 4, then 1, 0, 1, 4, 9, 16, 25. Okay. Now, all we have to do is we have to multiply these values with the corresponding probabilities. Okay. So, we have to, so if I write it down here, so variance of x is nothing but x minus mu whole square into, or let us say if I write in small x, then p x, okay, or you can write in capital terms also just to represent the formula. Now, here we can actually now substitute the values. We can have, so this one does not have any implication here, but here this one has. So, 25 into, so the corresponding probability is going to be 2 by 36, this is for 2, then we will have 36, sorry, this is 16, 16 into 3 by 36, then I will have 9 into 4 by 36, then I will have 4 into 5 by 36, then I will have 1 into 6 by 36, then I will have 0, then I will have again, it is really looking a little cluttered. So, let me just create a box around this, so that we do not mix things up. And then here we will have again 1 into 5 by 36, and then we will have 4 into 4 into you will have 9 corresponding is 4 by 36, then I will have 9 into 3 by 36, then I will have 16 into 2 by 36, and then finally I will have 25 into 1 by 36. Really messy. What we have done, we should have used a separate page, but that is how it is. The formula is this. So, we are basically using this value x minus mu whole square and corresponding probability. Okay. So, this is how we calculate this. Now, we can also, we could have also used this formula instead of this, we could have also used expectation of x square minus expectation of x whole square. Okay. So, we already have the value of expectation of x, we already have the value of expectation of x square. So, all we need to do is to sort of substitute these values, and if we do that, we will see in both the cases we are going to get the same result. Okay. All right. So, that is the idea of variance, and we have already shown you how we can actually derive this formula from from this one. So, that is really important. We are going to use that. With this, we sort of end the discussion on variance. Now, let me talk about covariance. So, we will talk about the rules of variance and covariance later, but before that let me actually talk about covariance. Now, covariance, as we know, we already perhaps know what is covariance, right. So, till now I was talking about one random variable, but when I talk about covariance, so I am talking about more than one random variable, right. So, I am talking about covarying things. So, when they are covarying, so that means of course, there are more than one random variable. So, how we write about covariance is the same way we the way we have written about variance. So, covariance, we used to write covariance x y is 1 by n summation x I minus x bar into y I minus y bar, right, over all I. So, all the values. So, what you do is you take the difference of each x values from corresponding x bar, and similarly you take the difference of all the y values from the corresponding y bar, and you multiply them and you sum them up, and then you take the average. Now, in terms of expectation of x y, what you write is expectation of x I minus x bar into y I minus y bar. Okay. Or you can actually write, you can simply, when you are talking about a random variable, so perhaps you do not have to mention the i's, you can simply represent this way. Okay. Now, if we expand this, what we get is, we can actually expand this, right. So, we can get expectation of, let us say, x y, x y bar, x bar y plus x bar y bar. Okay. So, if we use the expectation rule, what we will get is expectation of x y minus expectation of x y bar minus expectation of x bar y, and then finally expectation of x bar y bar. So, what we will get expectation of x y, and here again you know that y bar is constant. So, you can take the y bar out as per the second rule of expectation. So, y bar expectation of x, and then you can take x bar out, expectation of y, let me reduce the screen size, and then I will have, now I have two constant terms here, right. So, expectation of x bar y bar is nothing but x bar y bar, right. Now, what I get is expectation of x y minus, this is going to give me expectation of x is nothing but x bar. So, it is going to be x bar y bar, and expectation of y is going to give me y bar. So, that is going to be x bar y bar, and then I have a x bar y bar. So, it means expectation of x y minus x bar y bar. So, that is basically the formula of covariance. Okay. So, with this we sort of end the discussion on variance and covariance, and in the next lecture we are going to see some rules of variance and covariance. So, with this we end the lecture here.